In this video, we want to start having a look at circle geometry, so looking at the properties of circles. In this video, we specifically want to look at a couple of the properties that have to do with arcs, angles, and chords. Now, before we start diving into that, these are some of the definitions that you need to know. So some terms that are going to be used and you need to be really clear on what they mean. So if there's any words there that you're not sure about, you need to copy that diagram into your notes. So our first property says that equal arcs subtend equal angles at the center of a circle. So subtend sort of means that these arcs form the same size angles. So we've got this length from this point to this point, that curved edge along the edge of the circle. It's got a length L, and so does this one here. So they've got the same length, and because they're the same length, this property is telling us that these angles are also going to be the same size. Now the converse, or the opposite, the reverse of that, is that if two arcs subtend equal angles at the center, then the arcs are equal. So if the angles here are equal, then the arcs have to be equal in length as well. Let's have a look at what that actually looks like. So here we've got two arcs. So this arc is 5.1 and it's subtending an angle of 85 degrees. And this arc over here between A and B is 2.5 and it subtends an angle of 42. Now, if we make those arcs the same length, so I'm going to drag this until it says 2.5 as well, then you can see, now it's not 100% accurate because it's rounding, but you can see that an arc length of 2.5 also makes an angle of 42 degrees. And that's going to work wherever we put it. So if that has an arc length of 9 now, all the way from C to D, if we make this one have an arc length of 9 as well, then they'll have the same angle subtended at the middle. Now we can also get some questions sometimes that look something more like this here, where they actually share an arm as well, but it still works the same way. So these arc lengths are equal and they subtend equal angles. Now we could also play with this the same way if we made, now I'm overlapping things. If we were aiming to get these angles the same, so if we move this until it's got an angle of 57, then our lengths will be the same. So it works both ways. So our second property is very similar. It says equal chords subtend equal angles at the center of the circle. So it's not talking about the arc lengths this time, it's talking about the chords. So the straight line distance for C to D is equal to the straight line distance from A to B. And that means that these angles in the middle are going to be equal. Now it works the other way as well, so the converse is true. So equal angles subtended at the center of a circle cut off equal chords. So this one is really closely related to that first theorem. If we change this to chords instead of arcs, it's now measuring this straight line distance and is telling us, if we move that down here, so that's 2.1. If we make this one 2.1 as well, then we can see that they have that same angle in the middle. Our third property tells us that the angle at the center of a circle is twice the angle at the circumference subtended by the same arc. So what that means is that both of our angles are standing on this same arc here, but the angle, if we draw radiuses into radii, into the center, the angle formed here is going to be twice as big as if we draw in chords to the circumference instead. So that works here as well. This angle here is going to be twice the size of this angle. And this one, we've got both of our angles standing on this arc here. So we've got this one in here, which is 2 theta, and then we have this whole angle up here, which is theta. So the angle at the center is twice the angle at the circumference. So if we have a look at this one, we can see here that this angle is 130, so that's standing on this arc A to B, and half of 130 is 65. So if we move that around, we can see that that relationship is always going to hold true. So these questions, you can get them looking sort of 3 different ways. You can get them looking like this here, which is sort of the pretty straightforward looking one. We can get them if it's an obtuse angle in there, a reflex angle in the middle and an obtuse angle at the circumference. So 202 degrees here and 101 degrees over here. Or sometimes we end up where one of them runs through the center of the circle. So this line here is a diameter instead. But it's still going to hold, or we've got our 30 and our 15 over here. All right, so that's going to work any way we do it there. It also works with chords as well. If we have a look at the chord here, so that's angles standing on the same chord instead of standing on the same arc, that relationship still holds. Our next theorem is that angles in the same segment of a circle are equal. So you can also say that angles standing on the same arc are equal. So they're both standing on this arc here. So they've got sort of their bases there. So this angle here is theta, and this one that comes up like this is theta as well. So they're the same size. So for this one, it's often handy to sort of look for that bow tie shape. If we have a look at some examples of that, we've got both of our angles standing on this same arc or in the same segment between A and B. And we can see that they both form an angle of 44 degrees. So we can move those around and they're always going to stay at 44 degrees. If we move A and B, doesn't matter where we move them, you can still see that those two angles are going to be equal in size. And our last one that we're going to look at in this video is that any angle in a semicircle is a right angle. So let's have a look at some examples of that as well. So you can see here we've got a diameter, which is making it our semicircle, it's cutting it in half. And if we draw an angle out to the circumference, it's always going to be a right angle. So it doesn't matter whereabouts that goes, come around this side as well, it's always going to stay as a right angle. It doesn't matter where our diameter is. So in this video, we've looked at these 5 circle geometry properties. Now in class, in person, we're going to go through and prove all of these things as well. The last important thing you need to know for this video is that whenever you're solving a problem, whatever the question's asking, you always need to give a reason. All right, so that's having a look at a couple of theorems to do with circle properties.